All right, so we're back to this problem about graphing the distance, horizontal distance it's traveled with the height. And we were able to successfully do that for a point on the outer edge of the wheel. Now all we have to do is we have to move this thing in to where that thingamajigger is. So what's going to change here? And I think we can just work right off this picture. Okay, we know that where the center of the circle is, it was an important piece of that. And as the thingamajigger travels around, it's not changing where the center of the wheel is, the center of the circle. So that's good. So what does it change? Well, let's do the height first because the height's the easier one. We know that all that's changing is instead of a 14 there, we've got an 11. So this is going to change to 11 cosine of theta plus 14, just like we had previously on this one. Now let's get to the x values. Well, like we said, the center of the wheel isn't changing. And remember, the center of the wheel is located at 14 theta because that is the arc length that it's traveled. And we're still traveling on an arc length that's equal to the arc length of the outer edge of the circle. That's where the wheel touches the ground. So that part actually doesn't change either. All that's changing is now instead of a 7 pi plus 14, it's a 7 pi plus 11. That's still a 14 pi. Now this is a 21 pi minus 11. This is still a 28 pi. So the only thing that's different is instead of taking 14 theta plus 14 sine of theta, we need to take 14 theta plus 11 sines of theta. So let's go this, and let's just change these out. That's an 11, and that's an 11. Okay, and that looks pretty good. It's not all the way down to the bottom and bounce like we saw before. Notice it still starts at a height of 25 inches now that we're not all the way up. We can check another point to make sure that we're still on it. Like when theta is, let's go back to this. Let's go to the last one. We should still have 2 pi 25. That's not where I was expecting that to be. 2 pi 25. Oh, it should be 28 pi 25. That puts us right back to where we started. So it wasn't a big deal to go from the outside of the wheel to that interior point. We just had to adjust the radius on the left and rights and the up and downs, and that's it. So I think we got another question coming at us. Let's find out what that is.
Whew. While you guys are doing your work, I thought I'd get a few more laps and some exercise in. You know, and taking a look at my watch, my nice Garmin here, it's telling me that I was averaging 10 miles per hour. So one more graph that I want you to do here. X-axis, time. Y-axis, height. Now that you have a speed, okay, and think about what kind of speed that is. Is that an angular speed or a linear speed at 10 miles an hour? Now that you have a speed, can you graph time with height?
All right, so now we're doing height with time. This is actually going to be quite a bit simpler than what we just did before. So the piece of information that I gave you was that I was going 10 miles per hour. Now, we already know that our distances are measured in inches, so we're going to want to change that, and I feel like it would be appropriate to change hours down to seconds. So let's just do a little bit of unit conversions here. So we know that their 1 hour is 3,600 seconds. And then changing miles to inches. 1 mile is how many inches? Well, there's 5,280 feet in a mile and 12 inches in a foot. So that puts me at 63,360 inches in 1 mile. So what do we have here? I'm just curious how this is going to work. I'm going to take 10 times 63,360 and we're going to divide it by 3,600 and we get 176 exactly. How convenient that worked out. Inches per second. All right, so that's what we have for a speed. Now, what type of speed is that? That is a linear speed, isn't it? Okay. Now, I want to go back to when we had the height. Look at that, I'm right in the bullseye here. Let me move myself. Okay. We had the height graphed by the angle. Now we're going to graph height, but not with the angle, but with time, which is in seconds. So we're not changing any vertical stuff. We're just changing the length of the period here because we're changing our units. So we know that we're going to have to put something in here. Okay? And we're going to have to use this 170 inches per second to figure that out. All right, so we don't want linear speed. We're interested in changing the angle to a time. So that makes me think that I want angular speed. Now, what do I know about linear speed and angular speed? Well, I know that linear speed is just the radius times the angular speed. Linear speed equals just r times omega. So our radius here is 14 inches, so 176 equals 14 omega. Dividing by 14 on both sides, we get 88 over 7. Now, what are our units here on this? This is the angular speed. Angle is going to be measured in radians, and our time was in seconds. So we have an angular speed of 88/7 radians per second. So this doesn't work out quite so nicely. Now, how am I going to use that? Well, I said we need to figure out what the period is. We want to change this 2 pi from a 2 pi radians to some number of seconds for this period. Well, what do I know about a period? I know a period is 1 revolution. Okay, we want to get the seconds to cancel out. We want to figure out, we don't want the seconds to cancel out. We want to figure out what is the time in that 1 period for 1 revolution. So let's set this up. 88 radians over 7 seconds times, all right, let's see here, 2 pi radians is 1 revolution. So these cancel. Okay. We have an 88 over 2 pi, so the pi is going to stay in the bottom. The 88 over the 2 is going to reduce to a 44. We have 44 over 7 pi revolutions per second. Okay, 44 over 7 pi revolutions per second. Now we're going to run with that. What is the length of time to do 1 revolution then? How do we figure that out? Well, wouldn't that be just the reciprocal of this? 7 pi over 44 seconds per revolution. Right? It's not a very long time period. We should expect a pretty small number here, shouldn't we? I mean, going 10 miles an hour, it doesn't take very long for the bike to do for the wheel to do 1 revolution. This is our period. So let's go back to this, And let's say, okay, our period is equal to, what was it, 7 pi over 44. Now we know that period equals 2 pi over b. So we're going to say that this is 7 pi over 44 equals 2 pi over b. You know what, I should update this. This is no longer 2 pi. This is 7 pi over 44. And those, of course, would all change. All right, let's finish solving for b here. Let's see, I get 88 pi over 7 pi, which is 88 over 7. Now that kind of sounds like a familiar number to me. Look at this, 88 over 7 radians per second. And my b here is 88 sevenths. Why does that make sense? Well, that's the rate in radians per second. So if I'm going 1 second, I've gone 88 over 7 radians. If I've gone for 2 seconds, it's 88 over 7 times 2. It makes sense that we have to take the time times the angular speed, 88 sevenths. So our height equation based on time is going to be 11 cosine, what's our b? 88 over 7 times the time plus 14. So all we're doing is we're changing the period here. Let's go to the graph. I'm going to hide that one. We can delete these. And we're going to say h of t, the height at a given time, is 11 cosine of 88 sevenths t plus 14. Now look at that graph. What's going on with that? Wow, this is kind of nuts here, isn't it? Okay. Why am I not surprised by that? Well, as I'm graphing like this wheel spinning, it makes sense that it's going up and down a lot. I mean, where's 1 second? I mean, this is 2 seconds right there, and within 2 seconds, we're going to go up and down a whole bunch of times. What was our rate here? We're doing 44 over 7 pi revolutions per second. When I just get a rough estimate of that, okay, that means we're doing 2 revolutions. I mean, it's not perfect, but we're doing almost, or just a tad bit more than 2 revolutions per second. That's why it makes sense when I look at my graph. Look how many times I'm going up and down. Okay, it's pretty frequent, isn't it? Okay. So we see that graph, that makes sense. Now, I don't like this graph very much, and you probably don't either. It's way too condensed. So bonus problem, not from me asking you in the video, can we put this together with what we did when we graphed distance and height, but now let's do it in terms of time. All I have to do is multiply each of the t's in here, if this is in seconds, okay, by 88 over 7. Oops. All right, doesn't like something somewhere. Where is it? Extra parenthesis somewhere. All right, here it is. And then we have graphed the height and the horizontal distance, all with respect to time. So if I gave you a time, you should be able to find the horizontal distance and the vertical distance.